Okay, so I'm going to go through some short answer questions in this video. Look, I'm handpicking out some questions because it's fair to say it'll cover, the questions that I pick out will cover a sort of a broad range of topics, which will give you a pretty fair idea. If you can do all of these, then it's fair to say that you'll have a pretty good handle on the exam. Now the exam I've made the SACs fairly difficult this year, and I've made them quite lengthy. I'm trying to find out what our strengths and weaknesses are, how we can hack it. And at this stage, a number of you still have to do a fair bit of practice. Now I'm got plenty. Look, as next year you will have to religiously each week spend 3 hours a week minimum, probably more, just on specialists for your own private study if you want to do well. So not only is it making the most of your time in class, it's also doing practice and the basic skill stuff you can finish off at home. You really want to be doing challenging questions in class so you can have me there as your teacher explaining you through them. So the stuff that I'd expect you to do at home, well, that's stuff that you should be able to do with the aid of maybe some textbook solutions or something. You can work your way backwards. I'm going to just pick out some questions now. Let's go through them. Similarity was not done very well by a lot of students. I don't know why. We got that this triangle AEB is similar. Why is it similar? Because that is similar to triangle ADC because, well, first of all, they share the same angle. This angle, we'll call this theta. They're the same. They also, well, these two lines are parallel to this line, so that means that this angle here, we'll call this theta 2, they're the same. And therefore, and they also have so they share the same angles, and I guess all we've really done is that we have this triangle, the one in the green, is I guess it's larger than this one in blue. Okay, so they're similar though. Now the thing is, a lot of you use sort of this length here and stuff. That is not going to help you too much. We're comparing triangle A from triangle B. Now how's the easiest way to do that via similarity? Now what are we trying to find? We're trying to find we're trying to find the length AB. So we're trying to find the length of this triangle, or sorry, this length AB. So let's have a look at what we know. Well, we know this length of this triangle, we know this length, but the thing is we don't know this whole length of this triangle, but we do know that that is AB, the length AB, and we add 10 to it. So let's go ahead and do that. I'm going to use the bigger triangle first. So the bigger triangle, the ratio of this length here and this length here is 30 to 20. And since that they're similar, since triangle ADC is similar to AEB, then therefore we're looking over here at the bigger triangle, and this is the smaller triangle. So we now want to make sure that on the top part of this fraction, we're looking at the bigger triangle. So the bigger triangle is going to be AB. We're looking at this length over here. That is going to be equal to AB plus 10. And the smaller triangle is just going to have that length which is similar to of AB. Pretty straightforward, this one. So we've got 3 over 2 is equal to AB plus 10 over AB. Rearrange or let's cross multiply. And when we cross multiply, we're going to have 3AB is equal to 2AB plus 20 which therefore gives us AB is equal to 20. There you go, it's pretty easy marks, that one. Okay, so continuing on, we're looking at a question here. How long will the value of the investment double? So first of all, we have to identify what this is actually asking. The biggest application to geometric series, or sorry, sequence, is compound interest. So we start with $4,000, and that's compounded annually at a rate of 0.65 or 6.5% per annum. How long will the investment double? Well, so first of all, we know that it's geometric. We know that it's geometric because we're multiplying, or this, the rate of increase is 6.5% compounded annually. So first of all, we need to know that we're looking at the geometric sequence formula, not the series. A number of you tried the series formula and just threw yourself out. Is equal to A to the R. We'll just call that N. So we've got 4,000 there is equal to 8,000. R, which is 1.065 to the power of N. Dividing the 8,000 by 4,000, we've got 2 is equal to 1.065 to the power of N. Okay, so you could do a little bit of trial and error, I guess, put it in your calculator and try and estimate some value of N for which 1.065 to the power of that number is going to equal 2. But the thing is that you really need to show that mathematically. So what we're going to do is we're going to take the log of both sides. So the log of base 10 of 2 is equal to the log of base 10 of 1.065 to the power of N. And I know that you guys will cover this in methods later, but one of the log rules is that if we've got log to the base, just say A to a B, if that's to the power of N, then we can therefore, this N can go over here. These are equivalent. That's the equivalent of N log A base B. So what we can do there is, using this rule that I've just explained, is this N can then go to the front, which therefore means that we have, let's go, running out of room here, N log to the base 10, 1.065 is equal to log to the base 10, 2. So rearranging, therefore, we've got that the N is equal to log to the base 10 of 1.06, log to the base 10 of 2 divided by log to the base 10 of 1.065. And when you do that in your calculator, you'll get a value of N of 11.006 years. So I'm just going to say that N is equal to 11, or approximately 11. So it's going to take 11 years. All right, let's go ahead and find another question to go over. You can do those ones. Let's do this one. Find the coordinates of the points where x plus 3y equals minus 11 intersects the circle. Well, what's this going to look like? Let's just sort of rearrange this one for the time being. We've got y is going to be equal to minus 11 minus x divided by 3, which is equal to minus 11 over 3 minus x over 3. So we're going to have a graph which looks something like x equals 0, y equals. So we're going to have a graph which, first of all, we need to know what that looks like. it's going to be, so it's going to cross the axis as about minus 11 over 3. And it's going to be a negative, it's going to have a gradient or slope down like so. We don't really need to know what this is, but basically this is going to intersect with a circle, and the circle is going to, let's just draw any circle. The thing that you notice about that, and the reason you don't get it, this is not going to get you any marks, but it's actually going to intersect twice, just by looking at that. So when you had a question similar to that, and in your SAC, you basically just had to finish off some chapter 6 questions in preparation for your SAC, and a number of you just didn't even do that. So let's look at this question. This stuff is examinable. Just because I don't spend 2 classes on it doesn't mean that it's not assessed. It's just that we needed. I actually was putting the emphasis on you guys studying this at home. Now, first of all, if you know that if these points of intersection, what do you notice about them? They have the same x coordinate and they have the same y coordinate for both. Same over here. We have the same x. We'll call that x2. y2. They're both the same for both of those things. So so that means that the x for this equation up here is equal to the x over here. So it would make sense to then go, well, x is equal to minus 11 minus 3y. We'll call that 1. And then go ahead and put that into 2. I know it's a bit sloppy at the moment because it's hard to write on my computer. So we've got, let's put that into 2. So we've got minus 11 minus 3y squared plus y squared minus 10 minus 11 minus 3y plus 4y plus 19 equals 0. Looks very daunting. Let's go ahead and expand those out. You can do that in your calculator if you like, to avoid making mistakes. We've got 121 minus 11 times minus 11. 121 minus 3y times minus 3y is 9y squared. Minus 3y times minus 11 is 33y. And there's going to be 2 of those, so it's going to be plus 66y plus y squared plus 110 plus 30y plus 4y plus 19 equals 0. Okay, let's collect our like terms. We've got 9y squared plus y squared is 10y squared. 66y plus 30y plus 4y, 100y. 19 plus 110 is 129. 129 plus 121 is 250. And that is equal to 0. So let me just go create some more room for myself, because when I made this revision sheet, I certainly didn't give enough room to get it done, especially when my writing's quite big today. So let me just continue. Oh, okay. I'll just have to perhaps continue down here. So we've got 10y squared We've got 10y squared plus 100y plus 250 is equal to 0. Let's take 10 out as a common factor, which is going to have y squared plus 10y plus 25 outside of 10 is equal to 0. You can then cancel both sides by, or divide both sides by 10. 0 divided by 10 is still 0. So we actually got y squared plus 10y plus 25 is equal to 0. And the reason why it just makes it so much easier then, because we can factorize this expression. Y plus 5 all squared is equal to 0. So therefore, looking at this, we can say that y is equal to, in order to solve for that, is equal to -5. So what we've found is we've found the coordinate. We've found this coordinate, but it only appears to be 1. So it only touches the axis once. Okay, now this picture up here that I was doing was just to sort of get an idea of what it's going to look like. But perhaps that line only crosses at one point. Okay, so we've got y is equal to -5. So therefore we go ahead and we plug it in. Now, so there will be examples where you'll have more than one coordinate, but in this case you won't. So we've got y, so therefore x plus 3y, so let's plug that into 1 over here. So therefore x is equal to -11, can't even remember what y was now. Oh, y was equal to -5, minus 3 times -5. So that's going to be plus 15, which is equal to 4. So we know that it only intersects the once, and the so therefore we're not finished yet, because the coordinates, so therefore the coordinates intersection there could be more than 1, but in this case it's just the 1, is 4 minus 5. Okay, let's go ahead and do another problem. Really should have given you guys more room in this revision sheet. Give the prime decomposition of 42,336. Well, 42,336. Now I'm doing this in my head, so forgive me. Divide that by 2 gives us 21,118. Divide that by 2 again, gives us 25, 25, 10. So we can divide that by 2 again, gives us 10,559. Yep. Now, what do we do? Divide? We can't divide it by 2 now. So let's try and divide that by. Let's pause that for a second. I'm an idiot. That's a 6/8. Really should invest in more calculators. Divide that by 2. I'm still pretty. It's good practice not using a calculator, because you actually 10,584. Divide that by 2 again. 5292. Whoops. 5292. We can divide that by 2 again. It's 2646. Divide by 2 again is 13. Oops. 2646. Divide that by 2 again, gives us 13 2, 3. We can't divide that by 2, so we can divide that by 3. That's going to give us probably 441, so which we could then divide that by 3 again to give us, what's it going to do? Divide that by 3 again is 147. Well, let's try to divide that by 3 again. This gives us 49. Okay, so we've divided that, 49, we can't use 3 anymore. Divide that by 7, which gives us 7, and then finally we can divide that 7 by 7, which is going to give us 1. So the prime composition, and look, these prime compositions can be used to find the highest common factors and so on. But look, you guys probably won't have to do this again. So, but it's still pretty cool. 1, 2, 3, 4, 5. So therefore 42,336 is equal to 2 to the power of 5 times 3 to the power of 3 times 7 to the power of 2. And that's our prime decomposition. Here's a hint, you will have a question like that on the short answer section in the exam. Easy marks. Okay, let's do another one. Let's find another question in there for you guys. You'll have a Venn diagram question on the exam. Work your way through similar questions. I'm not going to do those ones. You're in Year 11 Specialist Maths. You don't need me to explain that. Let's do some sequences and series, perhaps. Okay, let's do this question here, and we'll sort of might stop from there. Now, in terms of other questions to revise, just make sure that you revise your partial fractions and also circular theorems. That would be really important. There's probably about a total of 10 marks on the exam in circular theorems, so make sure that you can do those. I've already been through a couple with you in the multiple choice section. But let's do this one. Company sells cartoon cards, character cards in the following numbers, 30, 45. Well, that's an arithmetic sequence, so find the numbers in the 10th packet. So we want number in 10, so therefore we want t to the power of 10, or sorry, t10, 10th term, is equal to a, which is our starting value, plus n minus 1, 10 minus 1, and a common difference here is 15. So we've got 30 plus 9 times 15 is, I've got 135 plus 135. So therefore, we've got 165 in our 10th packet. If she buys one each of the first 10 packets, how many cards will she have altogether? This is a lot of the time where we started to struggle because we didn't realize what that meant. Well, if she buys the first packet, then, the first packet contains, I think it was 30. Second packet's 45. So she's bought all of these packets. How many cards does she have? Well, it's the first term added to the second term added to the third term. So we want to actually find the sum up to the 10th term. We want to find S10. So how do we go ahead and do that? Well, we need to use the right formula for starters, and that's where a lot of you are struggling with. Sum to the 10 is equal to, it's this one. I'm trying to do this all by memory. 2a plus n minus 1d. I think that's it. Hope so. Yeah, I think it is. So 10 over 2, 2a, which is 30 times 2, which is 60, plus 9 times difference is 15 plus 165. No, sorry, 135. So therefore we've got 5 times 195, which is equal to, so the amount of cards that she'll have altogether by buying the first 10 packets from this sequence is take away 25 from 1,000, so 975 packets. Okay, let's have a look and see what else we've got there. Megan's sister Bridget decides instead to buy each of the first N packets, so as to get at least 200 cards in total. How many packets does she need to buy? Well, first of all, that we need to find that we don't know what N is equal to, but let's let it equal 200, and then we know that we find that value for N, and then we can work out whether she needs to buy an extra packet or not. So for example, if N was equal to 13.2, then she would have to buy 14 packets. Okay, so 200. So what we need to do is, first of all, that 200 is equal to s to the, sorry, we need to find s to the n, and that equals n over 2, which we don't know what n is, 2a, which is 60, plus, what is it, minus 1. Common difference was 15 from memory. Have something like that, and that equals 200. Equals all of that. Multiplying through by 2 gives us 400 is equal to, let's expand these brackets out now. We've got 60n. What's that? 15n. So that's plus 15n squared. And expanding it out. Minus 15 times n. So we've got a quadratic equation here, and I guess we'd probably have to either factorize or use quadratic equation to solve for that. So we've got 15n squared plus 45n minus 400 is equal to 0. So in order to solve that, in order to solve that equation there, what have I done? Then we need to, what can we do? Look, do I try and take out 15? No, that's not going to. I don't think 15 is going to go into 400. So, look, let's use the quadratic equation. N is equal to minus b, which is minus 45, plus minus the square root of 45 squared, b squared minus 4ac. Probably should have taken out 5 as a common factor. Probably would have made it a bit easier for me. Anyway, that's 6,000 minus 4 times that. Okay, so minus 45 minus that is not going to give us an answer that's feasible. So therefore, n is going to be equal to minus 45 plus the square root of 45 squared plus 24,000, and that's all over 30. Let's do that in my calculator. Okay, so I've got n is equal to 3.87. So therefore she needs to buy 4 packets. Now, if I see you guys just sort of taking a guess and just working it out, I won't give you any marks. You need to show it mathematically. All right. So look, I think I'll stop there. I think I've done enough there for you. Fair to say that you need to go over. If I'm looking through the exam now, make sure that you focus on, have a look at the literal equations. There's plenty there. Look at your past SAC, look at some harder literal equations. Also, when looking at variables, say such as, I've got a circle, and I've got a radius. How do you find, one variable in terms of another? Please make sure you revise those from chapter 6 and also from algebra 1, because a number of you struggled with those. For example, like if you're trying to express a volume of a container in terms of something else, well, you can grab one variable and you using whether it's Pythagoras theorem or some circular property, some formula, you can have one variable in terms of another. So make sure that you practice those sort of questions, extended response questions. Apart from that, I think that your exam's not too bad, but once again, if you don't practice enough, you'll be strapped for time. That's how I've designed it. Good luck, and yeah, if there's any problems, just come and see me.